This is Mrs. O'Neill for AP Chemistry, Chapter 3, Section 7, Limiting Reactants, something that we've already talked about, but now let's make sure that we can do those problems. The objective is to recognize that one reactant may be actually used up in a reaction, and that's called the limiting reactant. It's limiting the reaction to go to completion. It's limiting how much product you're going to make. And if there's some left over of the other stuff, we call that in excess. So pause, fill in the blanks, and then play to hear my words. So the limiting reactant is the reactant that actually determines how much product we can actually make. It's the one that you run out of first. So it's going to make the least amount of product because, again, you're limited to how much you can make because of that reactant. The book shows you a ratio method, which is fine and dandy if that's how you like to do it. In my mind, the ratio method makes me think harder. In my way, I like to do the problems the long way. In other words, I just do 2 stoichiometry problems. I start with my reactant, get to moles of those reactants, then use the mole ratio to get to the moles of whatever product I want, compare those 2 mole numbers, those 2 mole values, and then finish the problem. So the one that gives us the least amount of moles is our limiting reactant. So here's an example. At this point, if you want to pause and see if you can do the problem, now that you've seen them prior and you did this all in Chem 1, see if you can get the answer. If not, again, play. And I think I'm going to show you, I show you what I do. Again, the balanced equation, find the moles of each product, find the moles of the product that can be formed from that reactant, decide the limiting reactant by the least number of moles made, and then finish the problem. So if anything, you should have gotten to this point. You should have a balanced equation from the information given. Like I normally do, I write down what's given to me here and what do I want here. Then all of these other words are meaningless. I don't need anything. All I need is the reaction, what are my values that I'm starting with, and what do I want as an answer. So at this point, you should have been able to do that. For chlorine and for KBr, you should be able to go from the mass they give you, use the molar mass from your periodic table, and go to moles of Br. So if we were to cancel out these units, I'm left with moles of Br here. Same thing with KBr. Start with the grams they give you, go to moles using the molar mass, and then using that mole ratio from the balanced chemical equation to get the moles of the bromine. So you should have gotten those 2 values. Now looking at these 2 values, which one is the less number of moles? The 0.0121 moles of bromine. So that's it. I can only make 0.012 moles. Knowing I have this much grams of these much reactants, that's it. I can't make any more moles than that from what I started with. So chlorine is considered the limiting reactant and the KBr is in excess. Okay, so now instead of finishing the problem twice, I only have to finish the problem once here. So I'm going to go from moles to grams using molar mass, again from your periodic table. And I get 1.93, again 3 sig figs. 3.205 is 4 sig figs, 0.855 is 3 sig figs, so my answer, I'm going to round to 3 sig figs. So the excess reactant obviously is the one you don't run out of. It's an excess, like I just mentioned in that previous problem. So you want to always know, though, how much product is really formed. So the yield is the amount of stuff you make. The actual yield is how much you made in lab. Remember that when you're doing lab experiments, it's not always the perfect conditions. It's not always under standard conditions. You got wind blowing all over. You might not have a calibrated balance. So these are all things that could mess up what you actually get in the lab compared to the theoretical yield. And that's how much you should make according to the stoichiometric calculations. So percent yield is that part to a whole, right? I always say it's part to a whole. So it's always going to be the actual yield to your theoretical yield. The actual, again, is what you made in lab, which is usually less than what you should have made. And again, if we're dealing with percent, we always want to multiply by 100. So here's our analogy. Again, actual is always the less. kind of like what you get on your test versus what you should have gotten on your test, right? You all want 100% on your test, but most of you get a little less than 100%. So it's how much you actually got divided by how much you should have gotten, and that's how you can figure out your test grade or how much you can figure out your percent yield. And again, don't forget to multiply by 100 because we're dealing with percent. So here's an example. So another reaction. It's giving you grams of how much grams of the Cl2 you produced, but only this is how much you actually made, right? So again, if I didn't know any better, again, I would take the small over the big. The small tells me how much I actually got in the lab, and the 0.86 tells me how much I should have gotten. So plug and chug. I don't know what else to say except for here's your balanced equation if you need it, but here's how much you made versus how much you should have made times 100 to get the 83%. And we remember for percent yield, we want close to 100% as possible. This tells me that my experiment didn't go very well, or I should have made better, better conditions to make my reaction go better. Okay, see you in class.